So, one of the conventions that mathematicians decided on is there won't be any radicals left in the denominator. And all we're really going to talk about today is how to cancel it out. And I'm going to say one quick thing about this. It says to cancel it out, multiply by the conjugate of the denominator on top and bottom. This is only if there are two terms. So, on, for instance, 11 through 14 on the notes, you'll notice that it goes from having one thing down here to having two things down here. That's when you're going to use that. I'm going to explain 7 through 10, and I think it'll be a little bit easier for 7 through 10. On number 7, there is a square root of 5 down there that we want to get rid of. This is really the only thing we care about canceling out. So what we're going to do is multiply it by itself. Because when you multiply a square root times itself, the square root cancels. Because this becomes the square root of 5 squared, the squared power and the square root cancel, and that's just 5. So don't forget that there is this 2 out front though. So then my denominator is going to become 10, because that's 2 times 5. Well, that's all well and good for the bottom part of this problem, but we can't just randomly multiply by a square root wherever we want. In fact, that has now changed my problem unless I multiply by one of them on top as well. Because then this is the same thing as multiplying by 1. And you're allowed to multiply a problem by 1. Sorry, didn't realize you guys couldn't see that. There you go. You're allowed to multiply things by 1. That doesn't change a problem. You can add a 1 in front of x at any point on any problem because it's just multiplying by 1. As long as you do it on top and bottom, you're keeping it balanced. So I have to multiply by the square root of 5 on the top if I did it on the bottom to get rid of my square root, which makes the top part, instead of 3, it's 3 square roots of 5. Which just makes this number a little bit easier to work with, because you could also consider this as 3/10 times the square root of 5. So that then, if you had other square roots of 5, you could actually add the fractions together. I'm not going to have us write our answers like this. This way is totally fine. But that's just why this looks simpler or works easier for problems, even though this one technically had smaller numbers to start with. Is because the square root isn't on bottom anymore, you can think of it as 3/10 square roots of 5, and you can add it to other square roots of 5 if you wanted to. There's not really a whole lot of purpose here other than to simplify expressions. And until you actually get to the parts of math where you have to use a bunch of square roots together, it doesn't serve a large purpose other than we're just simplifying, okay? So if you're getting a little frustrated with this section because it seems a little pointless, I get where you're coming from, but we're just trying to simplify our answer. Same reason why we simplify fractions, to make them easier to work with. And then I'm going to come over here to the next one. And 8 and 15 don't divide, so what we're going to do is split this up into the square root of 8 and the square root of 15. So now I can see that it's the square root of 15 on the bottom that I want to get rid of. So what I'm going to do is multiply by the square root of 15 on top and bottom. The reason why is because now the square root of 15 times the square root of 15, when you multiply a square root by itself, the square root goes away, because that would be the square root of 15 squared. And a power of 2 cancels the square root. You don't have to write this every single time. I'm just writing it right now to help you make sense of this problem. And then on the top, since those are both inside the square root, you can actually multiply the 8 and the 15. And that's going to give you the square root of 120. And then at the very end of a problem, you do need to try and simplify it. Over here, we just had the square root of 5, so I didn't really say anything. But on this one, we have the square root of 120. So I'm going to try and split that up in between two numbers that are perfect squares. I'm going to show you my process of how I usually find those. And scooch this over a little bit. There we go. So 120. 4 is a perfect square. It goes in 30 times. Here's what you have to think about. Are there other numbers that go into 30? Yes. Are any of them perfect squares? 5 and 6, 3 and 10, 2 and 15, no. So that's actually all you can do. And then the square root of 4 is 2, so that gets to come outside. And the 15 stays on bottom. Now, be very careful. This 15 is not inside a radical anymore, so you can't divide these two. Because this is inside, this isn't. Your brain is going to want to say, hey, guess what? 30 divided by 15 is 2. That's cool. That's awesome. Doesn't matter for this problem because one's inside and one's outside. So try and resist the urge to divide 30 and 15 here. Okay? We're going to do a couple more that just have one thing on the bottom. Number 9 has variables. One thing you can do before you get this process started is see if you can divide these two. 32 and 3 don't divide, just like I had tried to divide 8 and 15 and it didn't work. 32 and 3 don't divide, so I'm going to keep those the same, but this would have a power of 1. And just like we talked about on the top half of the notes, there are 4 more A's on the top than on the bottom. So we're going to leave a 32, a to the 4th on top, and the square root of 3 on bottom. I have combined these together. You can either think of it like I do of there's 4 more A's on top than bottom, so there's a to the 4th left on top. Or you can subtract the exponents. 5 minus 1 is 4. It will only go to the bottom if that answer is negative. Then I need to multiply by the square root of 3 to cancel it out on the bottom. Okay? So on the bottom, this is simply going to be 3. Those two square roots cancel and you just have the number inside left. On the top, I can actually do 32 times 3 since they're both inside. That's going to make 96, a to the 4th. Then I need to decide, is there a perfect square that goes into 96? Okay, 4 goes in 24 times. There are some perfect squares like 4, like so go into 24 again. So I'm going to keep going. 16 and 6. The only numbers that go into 6 are 2 and 3. Neither of those are perfect squares, so you know that this can't be broken down any further. And I'm just going to write that right here. 16 times 6. The square root of 16 is 4, so it gets to come out. But the 6 has to stay. Notice I left a little gap there. That's because I'm also going to try and take the square root of a to the 4th. Just a little reminder that when you do that, this is the square root, so you can put an imaginary 2 in the index spot. 2 goes into 4 twice, so a squared can come out, and there's none left to stay underneath. Just don't forget you have a denominator of 3 on the bottom. 4 does not divide by 3. Those are your numbers outside, so you can't simplify this. These two aren't allowed to divide because one's outside and one's inside. And number 10, you have the square root of 12. So you're going to multiply by the square root of 12. And when you do that, I would put the top part in parentheses because there are two things. And that square root of 12 needs to multiply to both of them. Okay, the bottom part is usually the easiest because it's just 12. Those square roots just cancel and you just have the number inside left. That's kind of the whole point there. On the top, when I go to do 3 square root of 2 times the square root of 12, remember to keep the rules simple. You multiply the 2 and the 12 because they're inside, but the 3 has to stay out front. And 2 times 12 is 24. And then square root of 6 times the square root of 12, there's no numbers outside. So you're going to go straight to the square root. 6 times 12 is 72. And you do need to see a 72. And, hang on, there you go. 24 can simplify. So I'm going to try finding a perfect square that goes into 24. And it's 4 times 6. And 72. 18 goes into it, but 18 still has a perfect square, 9, that goes into it. So I'm going to keep going. 8 still has a perfect square, 4 that goes into it. So I'm going to keep going. Decimal, decimal, perfect. Okay, with the square root of 4, that answer is 2, so I'm going to cross out the 4 inside, put a 2 out front. Square root of 36 is 6, so cross out the square root of 36, put a 6 out front. And then the only other thing I have to do here is there was a 3 outside of this one, so these two have to get multiplied. 3 times 2 would be 6 square roots of 6 plus 6 square roots of 2 over 12. Now, on this one, you do need to double check, can you divide the numbers out front by something? Those can all divide by 6. So my final answer, and I'm sorry there's no room left on the right, would be 6 divided by 6 is 1 square root of 6. 6 divided by 6 is 1 square root of 2. And 12 divided by 6 is 2 on the bottom. So focus only on the numbers out front, never the numbers inside the radical, because the number on the bottom should never be a radical. That was the whole point of what we did in this section. Okay, next up, 11 through 14. This is where you have two things in the denominator. And what you're going to do is multiply by the conjugate, or sort of like the opposite of the bottom, like this. So if it was 4 plus the square root of 2, you need to multiply by 4 minus the square root of 2. You just change that sign in the middle. And I'll show you why it has to be the conjugate in this first example, but I'm going to go ahead and set up the rest of these. And I'm sorry, the square root on this 3 got a little choppy. So this one is 1 minus 4 square roots of 2. So you need to multiply by 1 plus 4 square roots of 2. Sorry, I had way too much coffee this morning, guys. So my English skills are lacking a little bit. And then I'm going to do the same thing down here. And I'm just getting these set up for you to show you that the setup, oops, there we go. You knew I was going to mess one up eventually, right? That's what happens when you try writing too fast. So these should both be square root of 5 minus the square root of 3. And this one should be 2 minus 2 square roots of 7. All right, so that's your setup, is you're taking the opposite what's on the bottom. We don't care about what's on the top because it can be whatever it wants. The whole point is to get rid of the square roots on the bottom. Okay, moving on. I'm going to go ahead and multiply the top part. There we go. We have to distribute. So this will be 16. And then 4 times negative square root of 2, the 4 just goes out front. On the bottom, I'm going to show you the long way, and I'm only going to do this on number 11. On all of the others, I'm going to shorten it up. You have to distribute this 4 to both of these. So that'll be 16, and 4 times negative square root of 2 is just negative 4 square root of 2. They can't multiply because one's outside and one's inside, so they just kind of get written together. And then I'm going to do the same thing, but square root of 2 times 4 is 4 square root of 2. Square root of 2 times negative square root of 2. When you multiply it by itself, the square root goes away, but a positive times a negative is a negative. Every single time, guys, these two in the middle cancel out. That's what happens with conjugates. Negative 4 square root of 2 and positive 4 square root of 2 go away. That is why we use the conjugate, because it makes the square roots go away in the middle. And all you have left is 16 minus 2, which is 14. Now I'm going to check my numbers out front. I can divide 16, 4, and 14 by 2. So I'm going to do it. 16 divided by 2 is 8. Negative 4 divided by 2 is negative 2. The square root doesn't get to change because it's inside. And 14 divided by 2 is 7. Number 12. I am multiplying by the square root of 3 on top. So that's going to be 1 square root of 3 plus, the 4 is the only number outside. You can even put a 1 here if that helps. 1 times 4 is 4. And the only numbers I get to actually multiply are 3 and 2 because they're both inside. So keep in mind that rule of you can multiply insides together and you can multiply numbers outside together, but you can't mix and match. On the bottom, now that we know that the 2 in the middle are going to cross out like this, you can just do 1 times 1 and negative 4 square root of 2 times 4 square root of 2. Don't let this step overwhelm you. Start with the numbers on the outside. Negative 4 times 4 is negative 16. Square root of 2 times square root of 2 makes the square root of 4, which is 2. There should never, I repeat, never be an actual square root left here. And this is 1 minus 32, which is negative 31. Nothing goes into negative 31, so my numbers out front, which are 1, 4, and negative 31, can't simplify. So this is my final answer. On number 13 and 14, put these in parentheses before you get started so you don't get too confused. And I'm going to multiply the top part first. 5 times the square root of 5 is 5 square root of 5. 5 times negative square root of 3 is negative 5 square root of 3. So basically, when I multiply the 5 by these, it just puts a 5 in front. And then negative square root of 5 times the square root of 5. A negative times a positive is going to be a negative. And when I multiply the square root of 5 times itself, it cancels out the square root. And then negative square root of 5 times negative square root of 3. Negative times a negative is a positive. And since these are both inside the square root, we can multiply them. 5 times 3 is 15. So take it one step at a time, guys. Focus on the whole thing and you're probably going to get overwhelmed. Just focus on what your next step is. On the bottom, these two multiply to 5 because the square root cancels. And then the square root of 3 times negative square root of 3 is negative. Positive times a negative makes a negative, and the square root cancels. And there you go.